Hello everyone, this is Kalpana here. In this video, we're going to see a problem from Laplace transform. So let's get going. Problem here is to find Laplace transform of t square e power minus 2t cos t, right? So just compare this with t power n f of t, okay? Or just compare with e power minus 80 f of t. Okay, we are going to compare the given problem with L of e power minus 80 f of t. So here t square cos t will be our f of t, right? In order to find L of t square cos t, firstly we will begin with Laplace transform of cos t. L of cos t, we need to find this. Since we know that L of cos bt equal to s by s square plus b square, right? By comparing these two, we'll get b equal to 1. So substitute b equal to 1 in the formula, we'll get s by s square plus 1 square, which is s by s square plus 1, right? Now coming to L of t square cos t, right? We know that from multiplication by powers of t, or multiplication by powers of t says that if L of f of t equal to f of s, then L of t power n into f of t equal to minus 1 power n for n equal to 2. That is, the power of t is 2. So we'll get minus 1 power 2 into d square by ds square into f of s, that is L of cos t. Okay, because here our f of t is cos t. Okay, this is equals to minus 1 whole square is 1, right? Into d square by ds square, and the value of L of cos t is s by s square plus 1, right? So now you can write this as d by ds of s by s square plus 1. Then L of t square cos t becomes d by ds of, so here we can apply either u by v whole dash formula or uv dash formula. Okay, we are going to apply uv whole dash formula, which is u dash v plus v dash u. So now let's split this as u into v form. We'll get s into 1 by s square plus 1, right? This is equals to d by ds of derivative of u into v is, derivative of s with respect to s is 1 into v, 1 by s square plus 1 plus u into derivative of 1 by s square plus 1 is minus 1 by s square plus 1 whole square into inner derivative. Derivative of s square plus 1 is, derivative of s square is 2s plus derivative of 1 with respect to s is 0. So you'll get 2s, right? This gives us 1 by s square plus 1 plus into minus, minus s into 2s, 2s square by s square plus 1 whole square. Now take the LCM of s square plus 1 and s square plus 1 whole square. Right? So s square plus 1 into s square plus 1 is s square plus 1 whole square is our LCM. Then you will get, so in the denominator of first term you are having s square plus 1, just close 1 s square plus 1 and multiply this s square plus 1 to this 1. You will get s square plus 1 minus, in the denominator of second term you are having s square plus 1, so we'll just write this numerator as it is, without multiplying anything to it, right? Now this becomes d by ds of s square minus 2s square is minus s square plus 1 by s square plus 1 whole square, or we can write this as d by ds of 1 minus s square by s square plus 1 whole square. See, we have applied uv whole dash formula. Instead of applying uv whole dash, we can also apply u by v whole dash formula, which is u dash v minus v dash u by v square. Okay, let's see that again. Okay, let's see what we'll get by applying this formula. Minus 1 whole square is 1 into d square by ds square. L of cost is s by s square plus 1, right? And we can write this as d by ds of s by s square plus 1, right? We can write this as d by ds of, now we can apply u by v whole dash formula. U dash is derivative of s with respect to s is 1 into v, s square plus 1 minus u into v dash. Derivative of s square plus 1 is 2s plus 0, which is 2s, by v square is s square plus 1 whole square, right? Is equals to d by ds of 1 into s square plus 1 is s square plus 1 minus s into 2s is 2s square by s square plus 1 whole square, right? This gives us d by ds of 2 minus 2s square plus s square is minus s square, so you'll get 1 minus s square by s square plus 1 whole square. You'll get the same thing, right? Fine. Now we need to find derivative of this term with respect to s. So here we are going to apply uv whole dash formula. Is equals to u dash v plus v dash u. Now I'll write this fraction as u into v form. See, it's square, okay, not 2, square. Fine. This is equals to derivative of u with respect to s is minus 2s into v, 1 by s square plus 1 whole square, plus u, 1 minus s square into derivative of v, that is derivative of 1 by s square plus 1 whole square is minus 2 by s square plus 1 whole cube into inner derivative. Derivative of s square plus 1. Derivative of s square with respect to s is 2s plus derivative of 1 with respect to s is 0. So you'll get 2s. That is derivative of s square plus 1 is 2s. You'll get 2s here. Right? This gives us minus 2s by s square plus 1 whole square plus into minus 2 into 2s is 4s into 1 minus s square by s square plus 1 whole cube. Now take the LCM of s square plus 1 whole square and s square plus 1 whole cube. Right? S square, so LCM of these two is s square plus 1 into s square plus 1 into s square plus 1, which is s square plus 1 whole cube. In the denominator of first term we are having s square plus 1 whole square, right? So close s square plus 1 whole square and multiply this s square plus 1 to this numerator, so you'll get 2s times s square plus 1, and in the denominator of second term you're having s square plus 1 whole cube. just the denominator of this term. So we'll just write this numerator as it is without multiplying anything to it. Okay. This gives us minus 2s cube, minus into plus, minus 2s into 1 is 2s, minus 4s into 1 is 4s, minus into minus plus 4s into s square is 4s cube by s square plus 1 whole cube. This gives us 4s cube minus 2s cube is 2s cube, minus 2s minus 4s is minus 6s by s square plus 1 whole cube. Now we can write this as, just take 2s common from these two terms, we'll get 2s times s square minus 3, right, by s square plus 1 whole cube, right. Therefore, L of t square cos t equal to 2s times s square minus 3 by s square plus 1 whole cube. Fine. Now coming to the actual problem. L of t square e power minus 2t cos t. We can write this as L of e power minus 2t into t square cos 2t. Consider t square cos t as one function, right? Now, we'll apply first shifting theorem. First shifting theorem says that if L of f of t equal to f of s, then L of e power minus at into f of t equal to f of s plus a. For a equal to 2, you'll get s plus 2 here, right? Now, consider this as f of s because our f of t is t square cos t, right? Fine. If if f of s equal to 2s times s square minus 3 by s square plus 1 whole cube, then f of s plus 2 will be, just replace s by s plus 2 in f of s, will get 2 times s plus 2 into s plus 2 whole square minus 3 by s plus 2 whole square plus 1 whole cube. We have just replaced s by s plus 2. Okay, just replace s by s plus 2 in f of s, then you'll get f of s plus 2. I mean the value of f of s plus 2, I can say. This gives us 2 times s plus 2 into, expand s plus 2 whole square, you'll get s square plus 2 square is 4 plus 4s minus 3 by, here also expand s plus 2 whole square, you'll get s square plus 4 plus 4s plus 1 whole cube, right? This gives us 2 times s plus 2 into s square plus 4s plus 4 minus 3 is plus 1 by s square plus 4s, 4 plus 1 is 5 whole cube, right? Is equals to 2 times s into s square is s cube plus s into 4 is 4s square plus s into 1 s plus 2s square plus 2 into 4s is 8s plus 2 into 1 is 2 by s square plus 4s plus 5 whole cube. This gives us 2 times s cube plus 4s square plus 2s square is 6s square plus s plus 8s is 9s plus 2 by s square plus 4s plus 5 whole cube. This completes the problem. Therefore, L of t square e power minus 2t cos t equal to 2 times s cube plus 6s square plus 9s plus 2 by s square plus 4s plus 5 whole cube. This completes the problem. So we have seen a problem from Laplace transform in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.